know that you have a burning question for me. I can just feel it. I know what you want to ask me is, but Tom, what's an omega-3? All right, so we're talking about lipids, right? And lipids are really important in our diet. Some of them are essential because we can't manufacture them ourselves. We have to get them from our foods. But lipids are also very important in our cuisine because of the flavor that they give us, like for instance olive oil used in salad dressings, or for food preparation when we add some oil to woks or we do deep frying or whatever. So lipids, oils, vegetable oils are extremely important part of our cuisine and part of our diet. And where do they come from? They primarily come from seeds. We get oil from seeds by squishing them and having the oil run out, particularly of seeds that are high in oil. But you can also do solvent extraction of oils, and commercially and industrially that's very common as well. So we get oil from seeds, and the oils differ in their quality. And you've probably heard health claims about some oils where maybe unsaturated oils are better than saturated oils, and polyunsaturated oils are even better, and trans fats are bad and cis are good, and omega-3s, oh, we have to eat those in our diet. So all kinds of claims, health claims made about fatty acids, and because fatty acids make up oils. Well, let me show you what I mean. So you can see by the notes in this lesson that a lipid is made up of a glycerol molecule, which is don't you just love all this chemistry stuff? Are 3 carbons, and attached to each carbon is a long chain of additional carbons. And these are called the fatty acids. So this is the fatty acid part, and this is the glycerol part. So glycerol and 3 fatty acid makes up a lipid. Now, where the health, because the glycerol is always the same, but where the health differences are and the performance differences in the kitchen have to do with what this chain is like. Now, often there's lots of carbons here, 16, 18 or more of these carbons in this chain, and they can have double bonds or single bonds. If it's all single bonds, then these carbons each have 2 hydrogens attached, and so on. And that means they're saturated with hydrogen. They have as much hydrogen as possible attached. So that's a saturated fat. But, here we go. If there's a double bond between some carbons, then you lose a couple of hydrogens on those carbons participating in the double bond, and so they are unsaturated. They don't have as much hydrogen as they used to have. That's an unsaturated fatty acid. Because the hydrogens are on opposite sides of the chain in this example, this is a trans fat. These are not found in nature. They're only made industrially. And they're, currently anyway, they're considered to be not particularly good for you. And so you'll see no trans fats in advertisements about particular foods. So the alternative is to have the hydrogens on both sides of the chain. And this is called a cis arrangement, and cis fats are found in nature, and so they're considered to be good for you.